Yo, this is Mr. O, and today we're gonna go over with graphing polynomial given a factored form. So let's go ahead now. The very first thing I like you to do is find the polynomial by multiplying. Again, doesn't matter which one you multiply first. On this case here, I have negative x. I have negative of x plus 1, x minus 2, x minus 3 squared. I'm gonna multiply this one first here. If I multiply that, I'm gonna use the FOIL. I'm going to take care of the negative last. X plus 1, x minus 2. FOIL it, x squared, negative 2x, positive 1x minus 2. That will give us x squared minus 1x minus 2. The next one here on the left side, I have x minus 3. That means I have to write it twice. So you're going to FOIL it, x squared minus 6x plus 9. So therefore, I'm going to multiply the orange and the blue here. Um, So x squared times x squared is x to the fourth. X squared times negative 6x is negative 6x cubed. X squared times 9 is 9x squared. Then I'll multiply by negative 1x. Negative 1, I'm going to write it under. Negative 1x squared, negative 1x cubed will be over here. 1x to the negative 6x is positive 6x squared. Negative 1x to the 9 is negative 9x. And then the negative 2x squared, positive 12x, and negative 18. So therefore, my answer so far is x to the fourth minus 7x cubed. What is that? 16, 15 minus 13, right? Plus 3x minus 18. And then take note there's a minus here or negative in front, so I have to multiply them all by negative. So I will just have to flip all their signs. So the answer now will be negative x to the fourth plus 7x cubed minus 13x squared minus 3x plus 18. Okay, there you go. And that's your polynomial. And that's how you get the polynomial, okay? The next thing to do is number of turning points. We can get them from the graph, but we can know that one by remembering that it's always a degree minus 1. The degree of our polynomial is fourth degree, so minus 1, the number of turning points is 3. Zeros and multiplicity. You can get this one from the factored form. I have here x plus 1, set it equal to 0. I have x minus 2, set it equal to 0. X minus 3 squared equal to 0, but you don't put the square, just set it equal to 0. Solve for the x each of them, minus 1, minus 1. So here x equals negative 1, plus 2 here, plus 2 there, x equals 2, and plus 3 here, plus 3 here, so therefore x equals 3. So the zeros are x equals to negative 1, x equals 2, x equals to 3. But the multiplicity are m equals 1, m equals 1, m equals 2 here. Where did you get the multiplicity? Because the degree of the quantity or the factor of the negative 1 is coming from x plus 1. So this is 1 here, that's 1 there, this is 2. That's how you get the multiplicity. We're all good with that one, guys? Good. X-intercept, you can get the x-intercept from the zeros. Since that's negative 1, so this will be negative 1 comma 0. That's 2 there, so this will be 2 comma 0. That's 3 there, so this is 3 comma 0. We good with that? Y-intercept. Y-intercept is the number when the value of x is equal to 0. Or to make it simple, imagine that this is 0 here, that's 0 there, that's 0 there, that's 0 there. What's left? Only left there is 18. So therefore, when x is 0, the value of your y is 18. Degree here, look at your polynomial. What's the degree? It's fourth degree, or we call it quartic. A quartic is fourth degree, so that's an even degree, right? The leading coefficient is negative 1, the very first coefficient on your standard form, so that's negative. If you have an even and negative, look at your end behavior. On the left side, it's rise or falling? Falling, right? And then on the right side is also falling, fall, okay? So when you graph that one, Okay. We expect that it will cross the x-intercept -1. This is, let's say, this is -1, 2, 3. If you notice, I'm putting the numbers there. Another thing you need to know or remember, m equals 1 means it's going to cross. I put C there. M equals 2, m equals 1 and x equals 2. This will cross also here and it will bounce over here, right? The end behaviors both fall. So I'm going to put an arrowhead here, arrowhead going down also. Okay. Before I continue, I'm going to find the relative max and minimum. So you're going to need your graphing calculator here. You're going to punch in a calculator either the polynomial or the factored form. It doesn't matter. Okay. I would suggest that you do the factored form. You know why? Because what if you're wrong with your polynomial? Then your graph will be wrong also, right? To make it sure, you plug in the given, the factored form, okay? But again, if you do the right thing on polynomial, then you should get the right answer. But to keep it safe, I'm going to put the factored form, plus 1 minus 2 minus 3. So y negative x plus 1, x minus 2, and then what's that again? X minus 3 squared, right? You graph it. There you go. If you want to see the entire graph, you can go the window. You can go the Y max to be bigger, make it 20. Maybe we can see better. There you go, right? You can change it that way. You don't have to, okay? But for the sake of learning, this is your maximum. This is your maximum, relative maximum and absolute maximum, okay? Yes.
If it's like upside down, like would the maximum be the just how?
No. If it's going down like this,
Yeah.
it opens upward like a parabola, the vertex there is the minimum.
Oh, okay.
Okay, so let's find the absolute max. How? Second trace, go to the max, so 4. We're gonna take it to the left bound. The spider is there. Left bound. Enter. I'm gonna take it to the right bound. Go to the right side. Enter twice. So what's our maximum here? Negative point 0.1 and 18.2. Okay, let me write that down. Hold on, ma'am. Hold on. Negative zero point 0.1 and 18.2. Yes, what's the question, ma'am? Yeah, any one of this point. This is the point we're looking for, right? Anywhere here. Anywhere here. Because look, I'm gonna get the other max. This is the max point. This is the max point. Hold on, I did too much. That's the max point, right? I need anywhere on the left of that one, on the left that's going down. So I'm gonna go here. See that one? Enter, and I'm gonna go to the right side. Enter twice. So what do you get? 3 comma, oh, the y is 2.2 e. What is the meaning of e? 0. So the answer is 3 comma 0, right? So this will be, where's that one? So the other max is 3 comma 0. Relative minimum. How do you get the minimum? Where's the calculator? You're gonna go here. So second trace minimum, enter, and then go to the right side, enter, enter. What's the minimum? Negative 2.4, negative zero point 0.5. 2.4, negative 5. Okay. So what's that again? 2.4, negative zero point 0.5, I think, right?
Calculator back.
Okay. So now, watch here. Stay here. You're gonna graph it now. I la- Another thing that I forgot to graph here is the y-intercept. Where's the y-intercept? 0, 18. 18 is somewhere above here, right? Let's say that's 18 there. So the graph, and then this is negative zero point 0.1, 18.2 somewhere here. So the graph here, guys, will be like this. Watch here. Starting here in the bottom, go up, cross 18, bounce. Make sense? Okay. How do you know if it's balanced? If the multiplicity is 2 or even degree. Even multiplicity, I mean. It bounced on the x value that matches to that. Like here is x minus 3. We solve it, we get x equals 3. So it bounced on the 3 because the multiplicity there is 2. Make sense? Okay. So, and that's how you graph polynomial in the factor form. All right. As always, kaboom.